Bismillahirrahmanirrahim. Today we discuss about general features of transition elements. इनकी वजह general properties जो हमारे पास हैं. These are number one, all transition elements are purely metallic in nature. तो number one, they are metallic in nature. और अगर ये metallic हैं, it means their melting point, boiling point should be very high. So they have very high melting points as well as boiling point. Both are very high. We need a lot of heat for melting and boiling. Third one, some of the transition elements play an important role in chemical industry like titanium, like chromium, like manganese, like cobalt, like copper, like zinc. So these play an important role in chemical industry. Point 4 is they are hard, they are malleable and ductile because they change their shape by applying force. Malleable and ductile in nature. It means their shape can be changed by applying force when we hammer them. Next one, they are all good conductors of heat and electricity due to presence of free electrons. Next one, they all form alloys. Alloy formation is the important property of transition element. It is because they have similar atomic size so that one metal can be placed in the interstices or spaces of other metals. तो आप इनके alloy easily make कर सकते हैं. Now next property, that is seventh one. Majority of transition metals have variable valency. Variable valency. Their valency can be changed with few exceptions. All of the transition metals have variable valency. Point number 8 is these compounds mean transition elements in their compound or ionic state. They have colored. They form color compounds and ions in solid as well as in solutions. जब इनके compounds को आप पानी में डालते हो, they form a solution. They are colored in nature. Or in the solid state, they are also specific colors. Now next point is, they are very important points. They form stable complex compounds. And now one more point is there, that is so they act as catalyst in majority of reactions. For example, we take iron in Haber process to prepare ammonia, which use vanadium pentoxide V2O5 in contact process for sulfuric acid. We use nickel or platinum for hydrogenation of oil into ghee. तो ये बच्चे आपके different properties हैं और general features हैं transition elements के. Electronic configuration of transition elements. Now we discuss electronic configuration of transition elements. If we discuss about scandium, we know the configuration. Atomic number is 21. You know that we write 1s2, 2s2, 2p6, 3s2, 3p6. Then 4s2. Now count the electron. Now there are 20 electrons here. And then we write 3d1. तो अच्छा यहाँ लिखेंगे valence shell configuration. I like orbital configuration. This is the d orbital that contain 5 orbitals dxy, dyz, dzx, dx square minus y square and dz square. And this is the 4s orbital. तो अच्छा आपके पास जो मैंने आर्गॉन लिखा, दिस इज द नोबल गैस हैविंग इलेक्ट्रॉनिक नंबर 18. बच्चे आर्गॉन का एटॉमिक नंबर 18 है. तो दिस रिप्रेजेंट अप टू 3p6. दे रिप्रेजेंट argon, that is noble gas configuration. Now in scandium, after argon we have 4s2. It has 2 electrons in the s orbital and 1 electron in the d orbital. तो ये बच्चे आपकी configuration scandium की. Similarly in case of titanium, बच्चे आप D में 2 इलेक्ट्रॉन फिल करोगे because atomic number is 22. We got 4s2 and 3d2 as well. So we have 2 unpaired electron in titanium. In case of vanadium, atomic number 23, 4s2 is 20 and 1 electron, second electron, third electron means D3. It is D3 means there are 3 unpaired electrons. In case of chromium, electronic configuration of chromium ends at 4s2 and 3d4. But one thing should be in your mind, बच्चे एक चीज़ बड़ी important है कि आपको elements को लिखना होता है in the stable configuration. Now D4 and D9 are not stable configurations, तो आप इनको स्टेबिलिटी के लिए रूल ऑफ स्टेबिलिटी आप इनको कन्वर्ट करते हो 4 को 5 में एंड 9 को 10 में इन ऑर्डर ऑफ मोर स्टेबल configurations. Now how we write this configuration? Look at that, chromium D4, तो इट मीन D4 इज नॉट पॉसिबल. ये बच्चा आप जब D में 4 इलेक्ट्रॉन आएंगे तो यू नो दैट आपको इसको 5 करना है, तो आप इसका एक इलेक्ट्रॉन मतलब S में से एक इलेक्ट्रॉन रिमूव करके और यहाँ बच्चा 5 पूरे करोगे. वी राइट 1 2 3 4 and 5. Now count. The configuration of chromium is we rearranged as that is 4s1 and 3d5. Total electrons are 6 here, and here we have 6 electron as well. So electron is same, but we arrange the electron according to rule of stability. Now in case of manganese 4s2 we have 20 electron, and now 21 22 23 24 and 25. It is d5 complex. Now we write 26 as 4s2 is 20 and 6 electrons in the d orbital. ये आपके 5 हो गए, and now we have pairing of electron take place. This is the configuration of iron. In case of cobalt, it is your d7 complex, means 4s2 and 3d7. For 27 we write 1 2 3 4 5 6 and 7. Similarly बच्चे, you got 8 electron in nickel in d orbitals 1 2 3 4 5 6 7 and 8. In case of copper it should contain d9. So आपको बच्चे d9 को 10 में कन्वर्ट करना है. अगेन आप एक इलेक्ट्रॉन s का शिफ्ट करोगे इनटू d ऑर्बिटल, दैट इज 1 2 3 4 5 6 7 8 9 and 10. This is the configuration of copper. In case of zinc it is 30, means d10, very stable configuration. We have 4s2 and 1 2 3 4 5, then 6 7 8 9 and the chromium and copper are very important because chromium में आपको इलेक्ट्रॉन शिफ्ट करना पड़ रहा है S से D में, and similarly copper आपको इलेक्ट्रॉन शिफ्ट करना पड़ता है 4s से 3d में. That's why they are very important configurations for the board exams.